so we are already here, point 4, using SpineInterface to manipulate the DB painlessly, I wrote. So that is something, so how do I put this? Basically, you could basically develop your own model. If you, for some reason, you don't want to use SpineOpt, or if you want to do some data manipulation, and then, for example, compute some demands on the fly, and then update your database. This is what we are going to do, actually. Update your database, and then feed that updated database to SpineOpt. You can do it with a package that's called SpineInterface. So I will do that now. I will add a new tool to my workflow, and I will do it by expanding this arrow here next to the tool icon. I will press new to create a new tool, and I will call it double demand. So yeah, so here in this interface here, I create what we call a tool specification. So I need to specify a little bit, a couple of things about my tool. First thing is the name. So this is done, easy. And then we need to select, we can select among a few types. You see Julia Python comes executable. This one will be Julia because SpineInterface is written in Julia. So it's a Julia tool, and it has a program file that I will create right now. And I will call it double demand.gl, which is the extension one uses for Julia scripts. So now I have a double demand script that I can write. I will save this. I will open this in my text editor. I will close this. I don't want to write. I could write the script right here, but I feel better using my text editor. So maybe I should start by, before writing the actual script, I could bring the tool into the workflow. So you see, I now have this double demand tool here, and I can drag it and put it here. So it's part of my workflow. And then I will say that this tool works on the input database. So I will connect it like this. And I will select the tool, go to properties, and similar to what we did at the beginning, I will see that I have the URL of the input database available because I have this arrow here. And I will put that as command line argument to my tool. So now I have done that. I can actually use in the script, I can define a variable. So this is, now I will do a little bit of scripting, but it's very simple. I can define a variable that points to the first command line argument. And in Julia, you do it like this, simply. So args is an array of command line arguments, and I want the first one, right? So that's the URL. And now I will write this to use the SpineInterface package, okay? And I will call this function on the URL that basically creates an interface for me to use with the contents of the database at the URL. So with this, I think I can already run to see how it looks like. Now I need to wait a little bit for Julia to compile SpineInterface because I didn't set up the system image. I could have done it, but I wanted to show you how Julia compiles code just in time. And it actually takes, as you can see here, it took a while, but it ran. And here I have an output console, but my tool is not doing much. It's just calling this function. But once you call this function, you see some magic happens, and you have, for example, this function now available for you to use it. And the reason it's called node is because the node object class is in the input database. If in the input database we had something like fish or house or whatever, the function would be called house. So you could program like a very generic application using this. And you see that I can get collections with all my nodes and all my units, so I can iterate through them. But what I want to do in this tool is actually double the demand for all the nodes. So I will try to do that. And I will try to do it by heart without looking at my backup. And maybe I need to look at the backup. But the way you do it is you define a dictionary like this. And it will be mapping this demand symbol to another dictionary. So you will understand in a second. And what I will do here is I will loop over all my nodes. So I will write something like this for n in node. And I will start by showing in the console the node and the value of the demand parameter for that node. So this should work, I hope. So yeah, so you see, for the electricity node, I have a time series, and this is a compact presentation of the time series. For the electricity 2, I have 60 flat value. For the fuel and storage, I have nothing. All right, so yeah, so that works. And then what I want to do is define the new demand, and it will be 2 times the current demand. And I will store in my new parameters dictionary that value, and I will store it under demand. And then here I need to do a little bit of name tuple Julia notation like this. So I'm saying right here that the new demand for this node is what I just computed here. And if I did it right, I can just call this write parameters function that is also provided by SpineInterface. And I can pass my new parameters dictionary and the URL and a comment, the commit. And if I'm lucky and did all this wrong, this will actually double the demands in the input database. So I will run it. Oh, I hope I did it right. Okay. So if I look at the input database again, I will refresh it. And I will look at the node. It looks like it was 60 before for the electricity node, electricity 2 node, right? And here, yeah, I think this was duplicated, right? It was 200, 150. So it's working. I can actually run it again. Check. And we can see that it's definitely working. So I have the 240 again. And here I have even greater values. So you see that this works. This multiplication here works regardless of the type of the demand. So if it's a flat value, it will be a flat value. If it's a time series, it will be a time series where all the values are duplicated. So that's pretty decent. But then, so I will stop with this doubling the demand thing, and I will do one just one more thing to show you another capability of SpineInterface, which is to be able to access parameter values regardless of what is the type of the parameter value. So for that, I have planned to write a little bit of a loop. So I will define a couple of variables here. I will define, maybe I just call it M. So M will be the only model in the database. Because we have only one model, right? One model object. Then TV is going to be the only temporal block in the database. And then I will define, I will call it timestamps. I will define a collection of timestamps. But before that, what is better? Maybe I can do it directly. Yeah, so the collection will begin at the model start. So remember, all these are parameters that are defined in the database, and I can just use them in SpineInterface like this. So I will write model start, and the time step will be the resolution of my temporal block, and the end of my collection of timestamps will be the end of the model. So then I can write something like this, 14 timestamps. I can show, first I will just show the timestamp. So if I run this, let's see. Yeah, so you see, I have all the timestamps, 0, yeah, so hour 0, hour 3, etc. Yeah, so now as I iterate the timestamps, I will also iterate the nodes. And I will show the node, the timestamp, and the demand for that node. And here I will specify the time as t. So this is a keyword argument that you can specify for parameter values in SpineInterface. And the idea is that if you recall, not all our demands in the database are time varying, but still, we can be generic and we can say, anyways, give me the demand at that time. If it's flat, it's flat. If it's varying, it's varying. Doesn't matter. So if I run this, I have a lot of output, but we can say, maybe I should have done this the other way. Let me invert so it's clear. Yeah, let me invert. Let me iterate over nodes first, and then over timestamps. I think it's easier to look at it that way. So yeah, so we have we see that now for the electricity node, we have a value of the demand that is varying according to the timestamp. For the other nodes, it's just flat, and it's okay. SpineInterface does the work for you in identifying, in realizing that it's flat, and so it's same for all timestamps. So that's pretty nice, I think. And it's actually the end of the material I have prepared. And we still have 20 minutes to go. So I don't know, maybe now we can have some questions, or I don't know, maybe some impressions. What do you think? Is it good, or how do you feel? Maybe we can open the discussion now. Are there any questions first?
Yeah, I have a question.
Okay.
First of all, looks awesome. Great work. My question, I have a couple questions. One, is there an easier way to build a network than dragging in each of your nodes individually?
Yeah, okay, that's a good question.
And then the other is, can a node be sort of like a geographical place and then it has multiple energy carriers flowing through it in different ways and balancing in different ways? Or is it like, this is an electricity node, this is a gas node?
Yeah, okay. So I think I can answer the first one. So yeah, for the second one, maybe I need help. But for the first one, I can say that you can do it. For example, with SpineInterface, as we just saw. And this is something we do regularly in Energy Reform to bring data, for example, from a large Excel file into a Spine database. So what you would do typically is you would write a script like this, and you will have, like, for example, here in Julia, you have a package that's called XLSX that it's basically like an interface to an Excel sheet. So you can read Excel sheet, and then you can imagine that, as I did here, you could write loops to build a structure, Julia dictionaries, that you can then import into your Spine database. So imagine you will loop over the rows of an Excel sheet, and then for each one of those rows, you will create a parameter or an object or whatever. SpineInterface allows you to create any of that, and you will accumulate those in a dictionary. And then SpineInterface also allows you to kind of say, okay, insert all this into the database, and it will be like a programmatic way of doing it. I don't know if you get what I'm trying to say.
I wonder if I could
script it. You can do it through scripting.
But if I could just add there as well, you could very trivially do it if you saw Juha's presentation using an importer tool to your database. So you could very trivially have an Excel spreadsheet with a list of your connection names, the from node, the to node, or your list of nodes if you want, and you would very quickly be able to create an importer that would import that. And so you don't need to script in that particular case. You could just use the importer tool in an Excel spreadsheet or text file or however you wanted to do it.
Okay, and that would build the sort of the spine opt structure from that Excel?
Yeah, you can do that. And then you can also copy paste if you use the table view format.
Yeah. You could copy paste here, and it expands the table if you copy like a table.
Yeah.
Yeah, the importer works like this. You put the importer here, and you connect it to your database, and then you will have like a data connection here for your Excel file, and you will connect it like this, and then in the importer, you will be able to have like a table like this, and you will save stuff like, I need to add a mapping first. I'm kind of rusty on this interface, but Juha's presentation probably has the right workflow.
It would be nicer to have an actual Excel file there. So, but anyway, yeah, you can map the data.
Yeah, yeah, so it's possible, right? I think that's the point.
Yeah, I was just thinking if I mean, once you build it, it's there, but if you wanted to put in like 40 different nodes that are all, connected on one grid, and then another 40 that are in another grid, and putting all those connections and having it all manual would take a while.
No, totally, yeah. It's impossible to do it. This is a toy example that you can drag and drop from the interface, but yeah, and the other question was about the nodes.
Yeah, if the nodes are sort of carrier specific, or if you could have like a generalized node. So if I wanted to just make it like the Netherlands, and it has an electricity demand, gas demand, whatever, and then connect it to other nodes using different types of connections, or if it's like, this is the Netherlands electricity, this is the Netherlands gas, as separate nodes.
I mean, you have the two options. If you prefer to do it with a single node, that's absolutely up to you. And how do you model it, right?
I think you would have difficulties because if you maintain a node balance, then you can't independently anymore distinguish between the gas balance and the electricity balance. So I think you're kind of forced to do separate nodes for the different energy vectors.
Okay.
Yeah, so I think fundamentally the nodes represent what you want them to represent in that. So for example, in Manuel's example system here, you have a fuel node going into the plant, and you've got flows going into the power plant and flows going out to the electricity node. But actually, fundamentally, there's nothing different. But you and I know that the flows going into the unit is a fuel, and what's coming out is electricity. But from the model's point of view, they're just flows. And it's us that infer the kind of sectoral meaning on the thing. So you can use nodes, connections, and units and flows in whatever way you want to use them.
Yeah. I don't know if that answers your question.
It sounds like the answer is probably not, but maybe. But
yeah,
I think I'll probably have to play around with it.
Sorry, if I might interject. So mathematically, each energy balance equation is indexed over the node, the time step, and the stochastic scenario. So you can't have multiple energy carriers going through the same node without them mixing in the energy balance. So if you want to have Netherlands gas, electricity, district heating, whatever, you need to create separate nodes for them.
But you can make a group of nodes for the Netherlands, so you can have a handle on those nodes that relate to Netherlands.
Yes, but it's not it's a group of nodes at that point. Yes. It's no longer a single node.
Yeah, but what you said, like, I mean, I sort of followed what you said, but isn't it then that the row is the node, but then the column would be the different carrier types? So for each node, you could have multiple carrier types that have their own balances.
Yeah.
But I guess then it has to go through another node to convert or something. So yeah.
Yeah, and the balance happens for each node. So if you want an electricity balance that is independent of the gas balance, you absolutely need another node.
Oh, okay.
Yeah, I think Toby is right. I mean,
it's a converter node, right? With it would have something like an efficiency also, very common in how you model heating demand.
Yeah.
Like here we have a fuel node that gets balanced, and it's balancing fuel. And this will be converting it into electricity to balance electricity.
Yeah.
Yeah.
Still related to this question, at some point from someone I heard that you could define a flow through a commodity. Do those commodities help then with such a balance at one node, or is just a commodity just some sort of naming label?
At the moment, the usage we have for so you can define commodities, right? And then you can associate the commodity to a node. Says this is the electricity commodity. To tell SpineNob that, for example, this node is of the electricity commodity.
So that's also related to a node and not to a flow, so you can't use that. Okay.
I don't think so. What you can do in the commodity is specify some specific physics that you want for the node. And what is implemented right now is this PTDF load flow for the electricity commodity. So, for example, I could select this physics, commodity physics, and specify that it's a PTDF physics that will apply to these two nodes. And then these nodes became electricity nodes that follow the DC power flow model. So that's the usage of the commodity at the moment. But I guess this is unrelated to your question completely. Sorry.
Well, maybe just to answer how we've kind of done that in practice, it's as you have said, basically. So we would say in our model of Europe, for each country, have a set of nodes that each represent the different, let's say, carriers in that country. So hydrogen, one for each fuel, perhaps, and then electricity. So basically, you can use nodes flexibly to kind of dimension by region geographically, but also to dimension by energy carrier or commodity as you choose.
Yeah, exactly, as we did, right? So this is electricity commodity, this is fuel commodity. This is something you know as a modeler. Yeah.
And you can also create those groups to give them labels that way. But
yeah.
So there's a couple more hands up, Manuel.
Oh, sorry. Can you?
Omar, please.
Yeah.
Yeah.
I have a question because you mentioned that there were some restrictions or that the SpineOpt was only with Julia.
Mm-hmm.
Can you do the scripting with? But I did see the option of doing it with Python and other languages. So can you interface with that with other languages?
Yeah, absolutely. With Python, the main API, the SpineDB API, is written in Python.
Okay, so you can. Yeah.
What I showed, the SpineInterface is a wrapper around that to provide more flexibility and functionality and niceties. But in principle, you can do it with Python or any language that has Python bindings. And we can even do it through a socket. If you have a language that can use sockets, you can also do it
okay.
with that language.
Thanks.
Yeah. Next question. Sorry, I don't see the hands.
Mikhail is next.
Thank you.
Yeah, so I don't have a question. It's just an observation, and I'm probably going to repeat this a lot now in the beginning of the project. But as you can see, there's fantastic possibilities with building models here. I mean, it's extremely flexible, the SpineOpt tool, but that flexibility comes with a downside, and that is for an outsider who has not been part of naming all these parameters and actually formulating the model and implementing this. It's really, really tricky to see how you do things and what do these things mean, all the parameter names and all of that. So we are going to need to work on documentation. There is documentation, I have seen it, but it's I guess that it's more understandable for you guys who have been really into doing the programming here. But for us that are a little bit on the outside, it's hard work to understand that. And I also think that we should try to help this by that modelers can use some higher level tools to, I mean, if you have a standard thermal power plant that you want to put, that you just can grab something, you have standard parameter settings that you enter and boof, you fill that out here and get help with setting up the underlying SpineOpt tools. I think that we have discussed this towards the end of the Spine project. You called it archetypes or something similar.
Absolutely, 100%. And this is a challenge for Mopo and for the components were packaged, in my opinion, to provide some level of abstraction.
Yeah.
So I would like if I could drag something that it's all this together, like this, for example, be one single thing that I could have available. But I don't know what others think. I agree with you, Miki, on this.
Yeah, I think I also agree very much, and I think there's quite a few different ideas how to make things a bit easier for the user, but I think it's also something we need to be discussing quite a lot during the project. So, yeah. Herman.
Yes, I want to comment on that. I also agree. I see that there are many things, and if you are not that familiar, that can be a barrier. I wonder if there is a way to bypass all this. So, for example, in the models we use, there is just simply a database. There is a model that calls the database and runs. Is that a possibility also here? That you could just somehow set up the database, use a SpineOpt to run the model?
But what do you mean exactly? So
the database, for example, has, okay, these are the units, these are the characteristics of the units. The unit is connected to this node. There is another part that says all the connections, things like that.
Yeah, that sounds interesting. In practice, I am not sure how. I would like to look at that. Yeah, that sounds interesting.
Because that is at least how we manage the models. And What about Backbone, Juha?
Sorry, what do you mean? You can run also Backbone from here.
Yeah, but don't you have in Backbone? I don't think you have this interface. I will imagine that you just read a database, you run the model, and then you have results.
Well, we can use the same interface also for Backbone, but I think the most common way still to work with it is to use we have a set of Excel files for the data.
So my point is that it's okay. The people who are familiar with this that can do it, but they can also use the capabilities of SpineOpt without going into this. And that is a little aligned with what Mikael said, that, yeah, in the pure database, you can just say, okay, this is a unit, this is the characteristic of the unit, this is connected to this node. And at least for us, that is how we do it. And we find it like normal. That is the usual way. And with different models that we have in TNO and in PBL, that is the way how they do it. So I can imagine there can be a barrier from them and from some people in TNO to try to get familiar with all these interface. But one way is just to offer the possibility. Okay, you can do it like this, or you can do it directly database, and as long as everything makes sense, you should be able to run the model.
There is the possibility, of course, to import data from Excel sheets into the database, because the SpineOpt model is actually just the input database. But then you still need to know all the parameter settings that should be imported into the database. Manuel, help me out here. Isn't there a tutorial how to do that?
Yeah, we have a Hydro tutorial that brings data from an Excel file into the right parameters in SpineOpt.
So if maybe I could just say something that the kind of way we went about structuring this tutorial was to introduce the very kind of fundamental building blocks one by one, and to try and help kind of convey an understanding of what each fundamental element does, and how, for example, creating a relationship from a node to a unit fundamentally triggers a flow variable within the model. And so to kind of build up that kind of these fundamental building blocks incrementally, so you kind of understand what they all do and how you can use that to implement different technologies. But of course, this is never the way we'd go about creating a model of a power system. We ourselves would never in a million years go about, using this interface to create a model. We do it ourselves using Excel spreadsheets or getting data from other places and building up the model programmatically. So and we've done for another project, we've done what's very nice is you can even within use Toolbox to define a higher level data structure. And for example, maybe this would be, the components idea, where you would define the entities at a higher level, like rather than units and nodes, you would define power plants and transmission lines and that sort of thing, and do a translation using SpineInterface from one to the other. So, so I think what you're saying, Herman, is exactly how normally we would use it too. It's just this is kind of the underlying flexibility that allows you to implement arbitrary technologies and systems and sectors, etc., etc.
I have another question.
Can I just say to that first? What I like to do here, though, is to do the alternatives, to do the scenarios. Once you have imported a system, then of course you can also import those, but sometimes that is the place where it's nice place to play with your model.
Yeah.
I have another question. Do you have a multi-year investment in SpineOpt? Is there multi-year investment?
Under development.
And I was just wondering, what if, for example, as an input data, because this is a case that we have a network, but for example, for 2025, there is not a connection between two nodes, and from 2030, because there is a line in construction, there will be a connection. So how would you do that here?
I don't remember.
Maybe I can try to answer what I think can be done, and you will tell me. I will imagine that maybe you could say, okay, for 2025, you have a line where the I don't know, the reactance is infinite. So basically, there is no line in 2025, and in 2030, the reactance is just the value that it takes. That is what I want.
Like that. I'm not very familiar, so probably someone will need to correct me, but you can define for any connection, you can define this candidate connections parameter and give it a time series. Is that the way we would do it?
So candidate connections is defining a connection as being available for investment. So it's an investment decision. The other options are any parameter in the model, as you've seen, can be time varying. So it can have a value changing by year, by month, by hour, however you define it. So we have different ways of defining that, whether time series or time patterns, that sort of thing. So that applies equally to reactances and transmission outages. So we've actually developed the functionality quite recently with PTDF load flow that anytime the network topology changes, it automatically recomputes all the network PTDFs and line outage distribution factors and things like that. Then the other tool that you have is the active parameter. So any element in your model, you can control its activity, whether it's in the model or not in the model, using is active, true or false. So I'm not sure if that works as time varying, but and then of course the other way you can do it, and this is something we do as well, you can also control it using we would typically create our networks programmatically, and we would have a series of additions and removals to the network at each years for different scenarios. So we would do it, let's say, outside of the model using the workflow tools rather than using functionalities within it. So there are different ways of doing what you're suggesting.
Okay. Okay, thanks.
Thank you for the questions. We are 6 minutes over time, so I can stay, but if there are more questions, I think it's an interesting discussion to have. No more questions? Okay, so I will thank everybody for joining and for your attention. And yeah, thank you. This was fun, and see you around. See you in Helsinki, some of you.
Thanks, everyone.
Thank you.
Bye bye.
Thank you. Bye bye.
Thanks. Bye.
Thank you. Bye.
Thanks a lot. Bye bye.